In this video, we're going to use InstaLOD to recover damaged scan data with unwanted artifacts using the new smoothing feature in the Mesh Toolkit. Then later, we'll jump into InstaMAT and add refined micro details. Let's dive in. All right, so here we are in InstaLOD Studio, and you can see that I have this 1 million polygon scan model. And you can actually see that we've had some problems when doing the reconstruction process from doing a photogrammetry scan of this model. You can see how all these bumps and deformations along the surface. And this is a kind of common thing that can happen when you're working with, certain kinds of scan processes like photogrammetry or other scanners. And, what can happen is the time of day or the surface type, you get some weird reflections in there, and it causes the reconstruction of the geometry to have these kinds of weird displacements and artifacts. And so what we want to do is we want to smooth out the surface of this mesh. And so we'd like to have more solid forms here, and we can create a base that we can later then use something like a sculpting application, or later I'll show you how InstaMat, how we can generate some better detail onto this mesh. But we want to have a nice strong base where we smooth out the surfaces, but we keep the overall volumes of this model. So what we can do is we can use one of the new features in InstaLOD 2026, which is the mesh smoothing feature in the Mesh Toolkit. So you can see I have here the Mesh Toolkit mesh operation selected, and I can just go over here to the smoothing operation, and I can increase these iterations. And as soon as I do that, you can see it gives us a few more options here. So what I'm going to do is I want to explain, kind of the difference between what are iterations and what is the damping factor. So the iterations you can think of are how many times InstaLOD's going to try to smooth out this model. So every time it's going to try and smooth out the topology, and it's going to do one step at a time over and over again to try and smooth out the result. And the damping factor is, how much, you can see the little tooltip here, how much each vertex or each point on the topology is allowed to move during each iteration. So if we increase the damping factor, this means that with every iteration that we do here, the topology is going to smooth out a lot more. So I could do, for theoretically, less iterations and a larger damping factor. Or I could, push and pull this in a different direction. I could decrease the damping factor, but, increase the iterations. And this is going to give us a more controlled, kind of concise type of smoothing operation. And so I definitely recommend that you experiment with these two parameters here to see how they adjust and manipulate the topology. So what I'm going to do is I'm actually going to increase the damping factor here to something like, let's do 1.21, and let's decrease the iterations because the damping factor is quite high here. So I'm going to choose something like 13. I also know that, you can see in this geometry, we have some holes and some splits, and, we could certainly weld these and close these holes using the Mesh Toolkit, but in this case, I'm going to maintain the topology as is, and I'm going to use the Preserve Boundaries feature here. And that just means it's not going to smooth out the boundaries and displace that geometry, but it's going to maintain that, which is really helpful in many cases. So now that we've set up the smoothing iteration, stamping factor, and boundaries, let's go ahead and hit start to process the mesh. And you're going to see it's a pretty quick operation, especially for 1 million polygons, but we're going to get a result that is slightly unexpected here. So you can see that the operation is done, but nothing seems to have visibly changed on the model. Maybe if you look at the topology, we might see that, it looks a little bit smoother, but really what's going on here is that the smoothing operation hasn't recalculated the normals of the mesh. The mesh normals are still set up in a way, positioned in a way where all these bumps are still, reflecting the light. And so this could be really helpful if you want to preserve a lot of that extra detail while smoothing out the mesh. But in this case, we really want to get rid of those. So to do that, we can use another feature of the Mesh Toolkit, which is to recalculate the normals. And so I'm going to set up a profile that kind of does all this automatically for me. So I'm going to go to my mesh operations, and I'm going to change this. I'm just going to call it smooth. And then I'm going to add another entry, and let's just call it recalculate normals. And this is going to be another Mesh Toolkit operation. And I'm just going to tell it to recalculate the normals here. And that's all I need to do really, because the default hard angle threshold is going to work fine for me. Now, what I can do to get these two operations to work together is I'm going to go to the profile settings and I'm going to choose previous output as input. And so that's going to allow me to take the InstaLOD to smooth out the operation and then pass the results of that operation into the recalculate normals operation. And then the last thing I'm going to do here is I'm going to tick off this circle with an arrow next to smooth, because that means that InstaLOD's going to export a model or generate a model, a mesh at this particular stage. So if I wanted a smooth and non-recalculated version as well as a recalculated version, I could have InstaLOD generate both of those for me. But in this case, I'm just going to have it recalculate the normals. So it's going to smooth, then it's going to recalculate the normals and generate a mesh after that is done. So now let's run both of these steps. I'll go ahead and hit start, and I'll tell it to run on the unmodified original geometry, and let's see what InstaLOD does. And there you go. You can see we have a much more smooth model here. I'll press F to focus the camera, and we can see what it's done here. It's done a terrific job of still, smoothing out a lot of the surface and topology. You can even see things like the kind of serpent symbol here on the side. We still have a lot of that information going on here. We still have the preservation of the geometry in the fingers, in the kind of like I'm not quite sure what kind of object, the instrument that might be. Even in the hair, you can see that we preserved a lot of the geometry, and in the face, we have like especially the major kind of bony landmarks in the surface of her face, which is fantastic as well. And so we can even have things like the wrinkles in the dress and stuff like that. It's done a really good job of preserving a lot of the details of the model while still giving us a lot of the larger kind of characteristics. We still have some of those deformations in the base here, but I think that's good for the character of the stone that we're trying to perceive here. And we can always adjust this, and we can adjust, the smoothing, the iterations and the damping factor to get a different result, but I think this one works for me, and you can certainly adjust those to taste. All right, so just to give you a preview of something that we can do after we've smoothed out the model is that you can see we can bring it into something like InstaMAT. And so with InstaMAT, I was able to reconstruct a lot of the additional detail here. You can see on the stone, you can see I can go back to that kind of a symbol here on the side. There's a lot of the additional details here. And we preserved a lot of these small micro details and all these etchings. We were able to reconstruct all of that. Even the wrinkles maintain their volume, you can see on the dress. And look at the face. The face restores a lot of that emotional detail. We can do that by, taking the base color that we have here. This was captured with the scan, and we could run it through a quick, height to normal creation here. We could take a lot of the details in here, convert it into a normal map, and reproject this onto the model to get a really nice result. So we have a much more smoothed out model here. You can see I also was able to optimize it with InstaLOD as well to reduce the polygon count and get a really nice result. And so I could do things like, adjust the normal strength here, and you can see how if I increase this, we can bring out more of those details. I can just lower it down here a little bit to make it a little more subtle if I wanted to. And I'm also going to, enable the base color so you can see what this looks like with the additional base color map that the model came with. So just to remind you, this is what the scan looked like before with all those deformations and bumps and all kinds of weird displacements. And you can see now, if I go back, this is what we were able to do. We could use the smoothing algorithm new in InstaLOD 2026 and also use InstaMAT to reproject a lot of those additional details on and get a really fantastic result that we can now use in our real-time experiences and applications. All right, well, that's it for now. Thanks for watching, and we'll see you in the next video. If you enjoyed this video, drop us a comment below, and don't forget to subscribe. For the latest news about InstaLOD, please visit our website, follow us on X, join us on Discord, or sign up for the Abstract community. You can find all the links in the video description below. Thanks for tuning in, and we'll see you in the next one.